watching this fantastic video. I'm very happy to have you today. I would like to take this opportunity to welcome every national and international viewer who is watching this program wherever in the world. My name is Olenjolaim. Simply just call me Olenjolaim. I'm a teacher and also an electronics and telecommunication engineer. So you can also call me Engineer Olenjolaim. Those are just the gifts that God has built in me and have been pursuing for some time. So I'm very happy to have you today, and I would like to take this opportunity, first of all, to welcome into one of our online institutions, that's called the Undergraduate Polytechnic Institute of Tanzania, OLENJOLAM. Simultaneously, because I'm teaching higher engineering mathematics and higher scientific mathematics, I would like to welcome you to one of our YouTube channels that's called Online Undergraduate Polyinstitute of Tanzania, OLENJOLAM. So, what are we doing? So possibly you have so many questions you meet with us for the first time. You are warmly welcome. We are very happy to have you. You have to stay connected, stay tuned. We are real here from Tanzania, and I'm doing this program for the Tanzanians and also for the international students who are benefiting and who are lovers of all prospective lovers of higher engineering, mathematics, and higher scientific mathematics. So you can be ask yourself so many questions. What the vision that you have in Online Undergraduate Polytechnic Institute of Tanzania in OLENJOLAM? Well, this is an assignment. It's a vision that we have. We are teaching and training undergraduate students who will be ready to extract knowledge and wisdom from the formal and informal instructions in engineering and science, including mathematics. Including mathematics, especially engineering or scientific mathematics, and combining the knowledge of the Word of God that we are going to learn it from the Holy Bible in order to solve real-life problems. So the main objective of Online Undergraduate Polytechnic Institute of Tanzania, in OLENJOLAM, is to train all our students to think differently. That is the main objective, to train our students to think differently and seek the solution, the engineering solution for real-life engineering problems that existing in our country, in our cities, in our towns, in our villages, in our families, and even in different other countries and even in other nations. So that's the responsibility, that the main visions. We have also some specific objectives. One of the specific objectives is to prepare our students for the test 1, test 2, just for the continuous assessment, and also prepare our students to be successful in the final exams or university exams in some of the places we used to call that. We have so many departments. One of the departments is called Departments of Higher Engineering and Scientific Mathematics. We are training, or we are teaching currently 12 modules, 6 modules for the semester 1 and 6 modules for the semester 2. And we are focusing on the curriculums of United Republic of Tanzania. So if you're Tanzania, or you're a parent, or you're a guardian, or a sponsor who have undergraduate students in engineering or science programs in any institutions or college or university, this is the right place for you, and this is the right place for your children, or for your son or for your daughter who is interested to be a successful engineer, and especially in mathematics, or in applications of mathematics in different engineering fields. So this is one, as I say that, this is chapter 1 of the chapter that you have to cover, chapter 1, that's called Function of Several Variables. And we are in lecture 5. So we have done 4 lectures. This is lecture 5, called Intro of Partial Derivatives. So you can access lecture 00, lecture 1, lecture 2, lecture 3, lecture 4 of several variables, because the modules of the day or the course is called Several Variable Calculus, and we are taking a reference of the syllabus and curriculums of University of Dar es Salaam, and also the syllabus of Zanzibar State University, and the syllabus of some other universities which are providing engineering programs, including St. Joseph, including different institutions in Tanzania and even internationally, who are real based, or who are really focusing on the knowledge-based, not competence-based. They are really focusing on knowledge-based in engineering and scientific and science disciplines. So, whenever you join any physical institutions or college, the first thing that you are going to do is registration. in every physical institutions or college or university, the first week is for registrations. And that's we call just orientation week for the first year undergraduate students. Whether you are ordinary diploma, you're joining with an ordinary diploma or undergraduate programs or bachelor degree, then registration is very important. So how are you going to register in our program? Well, it's very simple. You have to sign in. If you don't have email, you have just to open an email, sign in by using Gmail or Yahoo Mail. So you can sign in by using either sign in with YouTube. So go to YouTube, you can sign in by using your Gmail or your Yahoo. And then the second step, just you have to click the buttons which it has been written subscribe right inside at the bottoms of right hand side of your video. Once you click it, then it's changed into subscribe. So then the bell will appear. You have to click the bells and choose the option of all. So then whenever we add, because we're expecting to record and even upload and publish it publicly more than 500 lecture videos of about the high engineering and scientific mathematics on the focus of the curriculums and the syllabus of engineering and science in Tanzania, which will benefit Tanzanians and also benefits Africans and other students or other engineers or other undergraduate engineering students worldwide in every continent of the world. Because mathematics is universal. So it's a subject that be learned in every place around the planet Earth. So this model in many institutions or colleges or universities is being taught in first semester of the second year of engineering or science discipline. So I don't want to waste much of your time. I would like just to tell you also we have an online library that will tell you in the next sessions or later on. But again, you see, I have something else I didn't explain. This is in case you feel from your heart that you want to offer code your freewheeling Thanksgiving through that telephone number 0759 745331, and then your freewheeling Thanksgivings will be used effectively on paying the running cost for this program, so that more than 500 lecture videos of several of what of high engineering mathematics and high scientific mathematics will be in air to benefit the present and future generations. I know that possibly you are students who watching this program and then you have been given up on understanding high engineering mathematics or different, or you have given up on understanding the module or the course called the several variable calculus. I know you have used these different alternatives in order to capture the concept, but possibly those alternatives or different methods that you've employed, they have failed. I want to tell you that don't hate mathematics, don't hate engineering mathematics, don't hate higher scientific mathematics. You have to love it. And then don't make the final decision that you abandon the subject of high engineering mathematics or higher scientific mathematics. Just wait a minute. Try. You have never tried this method of learning high engineering and scientific mathematics in online undergraduate Polytechnic Institute of Tanzania, square bracket, Olenjolaim. So try it. Believe me that at the end of these sessions, you'll be encouraged, you'll be impressed, you'll be transformed, you will be actually motivated, and you'll be, and your will and even your vision and destiny will be restored, successful by the grace of God. So join me right now in the today session or into the today lecture, which is lecture 5. So today, I want to build a strong foundation. God has asked me and has sent me to you to build a strong foundation about the partial derivative, because I know that this is the concept we have never discussed. We don't teach our ordinary diploma engineering and scientific students, and we don't teach our advanced secondary education students. We teach them calculus, but we have been focusing on the calculus of the single variable function. So here we are focused on several variable function, and it's just the calculus means derivative or differentiation of several variable function. So I'm going to build a strong foundation in your mind, but you have to join me in lecture 60 when I will take you into the next stage. And actually, I'll be focused on second order. Today, I will end on the first order or first order partial derivative. And then in the lecture 6, I will teach our second order partial derivative and give you and teach you several examples. And then in lecture in lecture 8, in lecture 7, so I'm going to teach you about higher derivatives. Then we'll go to the Taylor's and Maclaurin's theorems. That's what, according to the syllabus of several variable calculus, which provided by the TCO. So let us go into the big picture of derivatives first. So actually the terminology called derivatives, this is it's an old branch of science, branch of mathematics. So we have the big subject of mathematics. Then the subject of mathematics is being divided into different branches. So listen carefully. Different branches. One of the branch is called the algebra. Another branch is called the probability and statistics. Okay? These are the sum of the branch. But another branch is one which is interesting. We are learning today is called the analytic. Okay? Then analytic, where we have different aspects there. But another branch, again, after having algebra, after having probability, we have analytic. We can have also about complex, or we just used to call it, algebra, probability, analytic mathematics. Then we have another branch of mathematics we call it geometry. Geometry is another branch. So when you take and look in depth the branch of analytical mathematics or analytic mathematics, then we find actual one interesting one. Yes, we find different aspects or different topics we can have. There we find trigonometrical function, okay, a probability function. Here we found about polynomial function, and then we find different functions. But one of the interesting branch of analytic is calculus. So also we have some other several branches, and even there we have some several branches. So now if we take a look on the very interesting branch of analytical, which is called calculus, we categorize it into three main branches, or the subject of calculus is divided into three main branches. And this is differentiation. So differentiation, and this is the point that we are talking about today. Then we have another branch which is called integration, another branch of calculus. And another branch of calculus is called differential. Say differential. This is not a new term for you. Differential calculus. Remember that OLENJOLAI sings different. OLENJOLAI sing different, teach different. Calculus. Differential equation, excuse me. So this is the differential equation. So Q, A, Q, and statistics. So today, we are not focusing in integration. We are not focusing in differential equation. We are focusing in differentiation. So when you take a look in detail, especially for the higher engineering mathematics, the branch of differentiation, we can divide it mainly into two branches. We have the first branch, we call it ordinary differentiation, okay? Ordinary differentiation. And then we have another ones which we call it partial differentiation, or partial differentiation, okay? Partial differentiation. So when you take this branch of partial differentiation, or in other words, we call it partial derivative, okay? So we will take it further and we'll see that we have partial derivatives of the different functions. Okay, we have partial derivatives, so you can find that here we'll be discussing that the partial derivatives of, it means you can have partial derivative of what? Of two variable function that has two independent variables, two variable function. We can have also partial derivatives of what? Of three variable function. We can have partial derivative of what? Of four variable functions. So it depends to the level of your study. But in higher and engineering mathematics and higher scientific mathematics, we just have to learn these two branches. So this is the point where we are today. Well, that is interesting. Remember that I teach you differently, I think differently, and also I expect you that at the end of this session, or at the end of this lecture 5, you are going to think differently also. And remember that I don't know everything about partial derivative. I don't know everything about several variable calculus. I just learned a small portion of it. I used to learn several variable calculus every day in my life. So what I know possibly to me might be 10%, but to you it may be 100%. But what I know, I have a responsibility to teach others. So now, let us have a focus after presenting to you about the big picture. Ladies and gentlemen, let us now take a serious focus on partial derivative. Partial derivative. Okay? So the fundamental question that always Olenjolaim has to ask himself and also has to ask his student is, what is partial derivative? What is partial derivative? What do you understand when you hear the word partial derivative? What is partial derivative? That's a very important questions. I have one of the definitions from one of the reference books, and I would like to share with you. So simply, whenever you hear the word partial derivatives in higher engineering mathematics, and even also in higher scientific mathematics, you have to think about differentiations of the functions of several variables, not single variable, right? So we define this one. This is one of the definitions we said that in mathematics, not in cosmology, but in mathematics, okay? A partial derivative, a partial derivative of a function, of several variables, a function of several variables, is its derivative. So is its derivatives of what is derivatives, the derivatives of the function with respect to one of those variables, with respect to one of those variables, with the other held constant. So actually, this is a very interesting definition, however, that it just uses kind of the technical or grammatical technical phrases. But let me explain. In mathematics, a partial derivative, say partial derivative, say again partial derivative. At least that you have that in your mind, that today what Olenjolaim taught me is about partial derivative. So a partial derivative of a function of several variables is its derivative with respect to one of those variables, with the other held constant. What does it mean? Partial derivative simply is a derivative of a several variable function with respect to one of its independent variable when other variables are kept constant. So when you're looking for the partial derivatives of the functions of the two variables, for example, we have to keep one variable constant and we differentiate the function respective to one variable. And then again, we have to differentiate the function with another variable while the first variable has been kept constant. So that the protocol and that the principle that we are going to follow, my dear student. So you can use this one, or just simply we can say that, or partial derivative is a derivative of what? Of a function of several variables with respect to one of its independent, because we know that in a function we have independent and dependent variable. With respect to one of its independent variable, while other variables, either 2 or 1 other variables, are kept constant. Are kept constant. So that's the second definition. So is the derivatives of a function of several variables with respect to one. So first of all, this is the derivative of a function, okay, of a function of several variables with respect to one of its independent variable, while other variables are kept constant. While other variables are kept constant. What does it mean? I will give you an example. But this means that, for example, if you have we have maybe a several variable function z is equal to x squared, y, then y cubic. Just a simple function like this one. So if you want to find the partial derivative of this function, so it means that we differentiate z, I will teach about notation soon, with respect to x, y is kept constant, right? So if you differentiate z with respect to x, while y has been kept constant, if you differentiate x, so it means y cubic is constant, then we differentiate x squared with respect to this one. The answer for this case is 2xy cubed. That's the meaning. So this is what we call partial derivative. It's a function of, so this is the dependent variable, this is independent variable, and this is independent variable. So if we want to differentiate z with respect to independent variable x, we have to keep y constant. If we want to differentiate z with respect to y, we have to keep x constant. So that's what we are doing. That's all about partial derivatives. We can just have some complexity later on, but the foundations is that's what you have to write in your mind. So it's nothing actual for the serious engineers and statistics like you. Okay, so that is the meaning or the definitions of partial derivative. Okay, so we have different types of partial derivative. Remember to register yourself. Click that button of subscribe so you get notifications once we add any new video. That's the meaning. When you subscribe, you will get official notification from YouTube once we upload any new lecture video. This is just lecture 5. So we are always uploading at least one video in this channel. Okay, so ladies and gentlemen, right now let me go and teach you about what I taught you, because these introductions of partial derivative, that's the name of the lecture or the title of the lecture. So let me teach you about notation. We have a special notation of partial derivative. So mathematicians worldwide established this special notation of partial derivatives. So there are different notations that whenever you see them in high engineering mathematics or in high scientific mathematics, you have to know that these are the notations of partial derivative. So I have a list of them, almost 6 notations. Okay? So we say that there are different notations. There are different notations of partial derivative. Different notation of partial derivatives. Okay, there are different notations of partial derivatives. Okay, the following are some of the notation. The following are some of notation of partial derivative. Okay, so with this one we say that this is 1. So 1, the first one
we use this notation that we can say that for the two variable part, derivative of a function of x, y with respect to x is the notation. So we don't have the normal d, because remember that in ordinary derivative we used to say that this is dy dx. So here we used to say that dy dx, so you have differentiating. So this is the partial derivative of function f of x, y with respect to x. Again, the partial derivatives of a function f of x, y with respect to x is written like that. But again, we can also differentiate that same function with respect to x to find the second order twice. So this is the second derivative of f of x, y with respect to x. But also we can differentiate that function twice with respect to y. So this is another notation x of y. So in simple language, whenever you'll be asked to find maybe a second partial derivative with respect to x, you have to understand that basically we have those notations. Or whenever you see these notations, it means to talk about partial derivative. But also you can go further, that you can find the second derivative of the function f of x, y when, with respect to I and then with respect to x. But again, so you can find partial derivative, the second derivatives of f of x with respect to y, with respect to x, of the function f of x, y. So, etc., etc. in this notation. Then we have the second notation. Interesting. The second notation is the one which is common. You'll find this is partial. It means partial derivatives of u with respect to x. Okay. We can also find partial derivative of u with respect to y. We can find also partial derivatives of z with respect to x if z is dependent variable. You can also find the second partial derivatives of u with respect to x. You can also find the second partial derivative of u with respect to y with respect to x. You can also find second derivative of u with respect to y square. You can also find set derivative of u with respect to x. Set derivatives of u with respect to x. So, etc., etc. So whenever you see this form of second notation, you have to know as engineer, whether electronics engineer or telecommunication engineer, that talks about partial derivative of several variable functions. Again, remember that, my dear students, with this big picture, what used to reveal this big picture of several variable or of mathematics in my mind every time. During the day times and during the night, I used to meditate this one, and to make you a different mathematicians in our own beautiful country where God lives. So, let me continue to give you different mathematical notation of partial derivative. Tell your neighbor that today we are learning the foundations, the fundamental of partial derivative, the introductions of partial derivative. And tell your neighbor, are you ready to love high engineering mathematics? Are you ready to love high scientific mathematics? Tell me in the comment section, please. Use the comment section to ask a question, and use the comment section to give me the feedback whether you understand what am I teaching you or not. The third notation, that partial derivative, we can notate as u subscript of x. This is partial derivatives of u is respected to x. Partial derivatives, or we can notate also this one as partial derivatives of u with respect to x. Second partial derivatives of u respected to x. Can also notate as set derivatives of u with respect to x. Can also notate that as first derivative of u with respect to y. Can also notate that second derivatives of u with respect to y and then x. Can also notate that third derivatives of u with respect to x, with respect to y, with respect to z. Can also notate that set derivatives of y, x, y, means set derivatives of u with respect to y, then with respect to x with respect to y. And then you can also notate that maybe even also sometimes that this is the sign with respect to x. So you have different symbols or different letters. If the function is w, you can find even also w, partial derivatives of w with respect to x with respect to y, etc., etc. So this is not a limitation. These are just some of notation. I've prepared the good news. I've prepared 6 notations of partial derivatives. I don't want the notations to bother your mind from now onwards of the partial derivatives. So the next, that will be the fourth one. The next which actually that we'll be using in this course is ff1, then x, y. This is the partial derivatives of this 2 variable function ff(x, y) with respect to x, one standing for x. And then you can also have ff2 with respect to what? So 2 stands for y, the second independent variable. So this is the first partial derivatives of ff(x, y). This is first partial derivatives of ff(x, y) with respect to x. This is the first partial derivatives of ff(x, y) with respect to y when x is kept a constant. And here, this is the first partial derivatives of ff(x, y) when y is kept a constant. Okay, so then we go again. We can have also ff(1, 1), ff(x, y), 1, 1. What does this mean? This is the second partial derivative of ff(x, y) with respect to x when y is being kept constant. Again, we have also this one. This is commonly used in this course. ff(2, x, y). So what does it mean? This is the second partial derivative of ff(x, y) with respect to y when x has been kept constant. Okay? Then again we have another notation. This is ff(1, 2). Then ff(x, 1, 1, 2). What does this mean? This is the partial derivative of ff(x) with respect. This is the second partial derivative of ff(x, y) with respect to x with respect to y. So when we so it means this one we can define this one. It's the second partial derivative of ff(x, y) with respect to x when y has been kept constant, and then with respect to y when x has been kept constant. So again we have the other one. So we have ff(2, 1). So ff(2, ff(x, y, 1). So this is the second partial derivative of a function ff(x, y) with respect to y when x kept constant, and then with respect to x when y has been kept constant. So these are the notations, etc., etc., etc. These are the some of the notations. Ladies and gentlemen, higher engineering mathematics is beautiful. And it's one of the favorite subjects that for the rest of your life, because you have to think how you can solve real life problems by taking this knowledge. And this is just a fundamental. It can change your way of thinking. In mathematics, we are training you how you can think faster and how you can define problems, especially the engineering problems. When we are teaching about engineering mathematics, we are teaching you how you can think fast and accurate, and how can you think differently concerning about and also how can you give out different alternatives, solutions of the particular engineering problems. So you have the first notation, ladies and gentlemen. The first notation, ladies and gentlemen, you have how many? So how many have I mentioned? So 1, 2, 3, 4. Okay, so this is 5. So now we are going to number 5. Number 5, number 1, number 2, number 3. Okay, number 3, number 4. Wait, they jump. This is number 3, number 2, number 4, number 5. Hey, wonderful. So the fifth notation, we can also notate the partial derivatives as this ff(x) of x, y for the 2 variables. I'm just simplifying the concept for the 2 variables. But also you can have this x, y for the 3 variable, like this. Just in the same thing.
This is the first partial derivatives of f of x with respect to x when y is being kept constant. This is the second partial derivatives of f of x, comma y, comma z with respect to x when y and z are kept constant, with respect to y when x and z are kept constant. Also, you can have f of y of x, comma y. So this is the second derivative as I told you. Also, you can have what? F of y, x, y, and then our function is x, comma y, comma z. So, etc., etc., etc. Again, in case of voting, or if you have for the two variable function, you have also another 6 notation which is used in some of the books, and this is derivative. So D, the capital D stands for derivative. So derivative with respect to what? So D1 means derivative with respect to the first independent variable, which is x. So this is D1 of x, comma y, and then here we have D2 of what? X, comma y. What does it mean? This means that the first derivative of f of x, comma y with respect to x when y has been kept constant. This is first derivative of a function f of x, comma y with respect to y when x has been kept constant. That's all. So those are the 6 notations of what? Of partial derivative. Are you enjoying the beauty of engineering mathematics? Tell me in the comment section, please. Okay, I forgot here in this notation. Let me do correction. This is d1, which is derivative of a function f of x, comma y with respect to x, and this is the derivative of function f of x, comma y with respect to what? With respect to y. Okay, wonderful, great. We are continuing. So after giving you the big picture of partial derivative, after defining the terminology or the vocabulary for this session or for this lecture of partial derivative, and also after presenting or after introducing you about the notation, the mathematical notations of partial derivatives, different mathematical notations of partial derivatives, right now, ladies and gentlemen who love several variable calculus, allow me to teach you about some of the about partial derivatives of partial derivative of two variable functions. Okay. So let me just give you examples. So you say that or categories. So categories of what? Of partial derivative. So we say that in math, so in calculus, we have what? We have these partial derivatives. These partial derivatives. First one, partial derivative of two variable function. Two variable function. In other way, we say that partial derivatives of what? Of first order. First order. Also, we have partial derivative of three variables function. Simply, this is steady order. Then simply it makes according to
level in curriculum, we have higher derivatives. Higher derivatives of 40 of higher variables function. Of higher variables function. Okay, variable function. So this is, we call it nth order. So these are the categories. So ladies and gentlemen, after presenting to you about those categories or classifications of partial derivatives according to the types of the several variable function, we have several variable function of the two independent variables. Also we have another ones of three independent variable and the other ones of more of nth independent variables. So now let us have a look of partial derivatives of two variables function. Partial derivative of two variable function. So that is partial derivatives of two variables function. So the rest, not the rest, because we also focus on the three variables function. Partial derivatives of two variable. This is also what we call the, we say first order partial derivatives of two variables function. So first order, so we call this title as what? Partial derivatives of the two variables, first order partial derivatives. So yeah, so we have to begin with this term. First order partial derivatives of two variables function. So in order to start this one, we like just to remind ourselves what we have learned in partial derivatives of the single variable function. Okay, single variable function. So we have to say that from, or recall, the first principle which we taught you in advanced level or in ordinary level, the first principle of ordinary derivative of single variable function. So recall the formula of first principle of ordinary derivatives of single variable function. So we say that if you have a function which depends on x, if you do remember, the first principle we say that to find dx of f of x, this is equal to limit as x or as small change in x approaches to 0. And this is when f of x plus small change in x minus f of x divided by small change in x. Or we used to say that the first derivative of single variable function f of x, this is the limit given as h approaches to 0. Then here we have f of x plus h if we let small change in x is equal to h of what? H. So this is about the first principle, formula of the first principle of ordinary derivative of a single variable function, which it's a function that just depends on a single variable, whether x or t. Okay.
T stands for time, X stands for maybe distance or some other parameters in engineering. Okay. So if that is the first principle we learned when we have been teaching you about derivatives of first order, then how can we transform this just like what we did in limits of the two variable functions in continuity of the several variable function? You just did. Remember our fundamental concepts on a single variable, and we translate it or define. So right now we can have another subtitle that titled the first principle of first principle of partial derivative. Okay, partial derivative of two variable function. SCT means it's abbreviations of the function. So we think that here we are focused with two variables. So we say that given a function which depends on x and y. So now we are going to have two forms of what the first. So the first partial derivatives of the function, this one with respect to the variables, the function is given as this one. So it's a given f of x, comma y. So it's saying then the first partial derivative of the function f of x comma y, the function f of x comma y, right, with respect to what? With respect to x and y is given as two formulas, is given as this. So remember, we say partial derivative is a derivative of several variable function with respect to one of its independent variable when other independent variables are kept constant. So for this one, we say that we apply from these concepts of the first principle. We may use either this formula or this formula. So we say that our partial derivatives, for instance, that are partial, means a partial derivative or partial derivatives of a function f of x comma y, this will be equal to what? So we have our limits, so we have limits is h. So listen carefully, and you have to look what you are going to change. So you are going to differentiate this function with respect to x when y is kept constant. So we say that this is limit as h approaches to 0. Then we have a function, it depends on the two variables, but we want just to increment only x when y is kept constant minus f of x. Then this is divided by what? By h. So this is the first formula when we differentiate the function respective to x. Remember that this is equal to also f of 1 x comma y. So if we differentiate the same function with respect to y, so we keep x constant, this will give us the formula limit as h approaches to 0 of 40 of f of x. So today we are keeping x constant, we are incrementing y by h minus what? F of x, and this one, so we say what? So this one we divide by what? By h. So simply, ladies and gentlemen, these are the two formulas of first principle of partial derivatives of the two variable function. If three variable function, also we are going to deal with it, nothing difficult. So now we have transformed your mindset from what you knew before this lecture 5 about the first principle of the single variable function into the first principle of the two variable function. So what can you observe from that formula? That's a very good question. So what we can observe, so observation of what? Observations of first principle. First principle that we gave it there. So what we observe that, we say the partial derivatives of f of x with respect to x, which is equal to f of 1 of x comma y, is obtained when f of x comma y is differentiated with respect to x when y is kept constant. When y is kept constant. Okay? Again, we said, so this is the first observation. The second observation, we say that the first derivative of f of x comma y is equal to what? Which is equal to f of 2 x comma y. This is obtained when the given function f of x comma y is differentiated with respect to y when x is kept constant. When x is kept and x is kept constant. That's what you observe. Okay? That's what you observe. Okay? So right now you have a big picture of first order partial derivatives of the two variable function. Now it's a time for me to do two examples, and then I leave the homework for you so that you can go through yourself. So ladies and gentlemen, I put the sequence of what I've been teaching you in the course of 47 variable calculus. This is example 8. So example 8, most of this question, or most of the questions of first order are asked. This is from the class notes of several variable calculus prepared at University of Dar es Salaam. So it says that you refer using University of Dar es Salaam notes. Okay? So the question asks you that find what? Find partial derivatives of z with respect to x, and what? Partial derivatives of z with respect to y. If z is equal to x cube y squared plus x4y plus y power 4. That's the given function. So solution. So to know that, what should you differentiate and what should you keep constant? Okay. So you've been given this question. So ladies and gentlemen, you have just to solve. This is Engineer Olenjolaim, who is doing maneuvers in higher engineering mathematics. Z is equal to x cubic, then y squared plus what? X power 4, y, then plus y 4. So being asked to find the partial derivatives of z with respect to what? So the first step, we say that find partial derivatives of z with respect to of the dependent variable z, okay, when y is kept constant. The function z depends on the two variables x and y. So if you want to differentiate z with respect to x, we have to keep y constant. Again, if you want to differentiate z with respect to y, we have to keep x constant. So to do this, we say that the partial derivatives of z with respect to x, this is equal to it. So y, we keep y constant. So it's partial derivatives of x cubic with respect to x plus what? Y also we keep y constant. Partial derivatives of what? Of x power 4, then plus what? Y power 4, partial derivatives of what? Of constant in 1, because or x power 0. So x power 0, this is equivalent to 1, remember. So the first derivatives of z with respect to x, this is equal to what? Differentiate this one, we get here y squared, then have 3x squared, then plus, so you have y, then you have what? 4x cubed, then you have plus what? Y power 4 times what is 0. So partial inverse of z with respect to x, this is equal to what? 3x squared y squared, then plus what? Then plus 4y x cubed. So this is the response for the first part. That's the response. That's what you have asked it to find. Okay? Okay, so again we have to find what? I have to find partial derivatives of z. So the second step, how to find partial derivative of z with respect to y. So simply we've been asked to find partial z with respect to y. So when what? When x is kept constant. So when x is kept constant. So ladies and gentlemen, we have z is equal to what? Is equal to x cubic y squared plus what? X power 4 y plus what? Plus y power 4. Okay? So to find it, we have to differentiate z with respect to y. So we keep x constant, so we take out of the derivative. So we differentiate y squared with respect to y plus what? We keep x power 4 constant and differentiate y with respect to y plus what? So we have y partial derivatives of y power 4 with respect to y. So this will be partial derivatives of z with respect to y. This is equal to what? So if we differentiate this one with respect to y, we get x cubic times what? Twice y power 1, right? Plus what? If you differentiate that one, it is x power 4 times 1. Differentiate y with respect to y, you get 1. Differentiate y power 4 with respect to y, you get 4y cubic. Therefore,
The response for partial derivatives of z is partial derivatives of what? Partial derivatives of z is respective to y. We get what? This is 2x cubic y, then plus what? Plus x power 4, and then this is plus 4y cubic. So this is what we have.
Wonderful. So you answered the question which you've been given. So we can do the second example, which is example 8 for the series. It's 2x cubic y plus x power 4 plus 4y cubic. Okay. So, ladies and gentlemen, let me present to you example 9. Okay, example 9. Find ff1 of x comma y and d ff2 of x comma y of given function. The function f of x comma y is equal to x squared e power x. This is the kind of the challenging question now, compared to the first one, which was polynomial function. Here we have a combinations of different functions. So plus what? This is plus cos of y over ln of x. Ln of x. Then minus a power x squared. Then we have c of y. So we have to find the first derivative of the function f of x comma y with respect to x, and find the first derivative of the function f of x comma y with respect to y, when x kept constant here, and here when y kept constant. And this is the given function. So let us go to the business. So solution. So you have to follow steps. So you'll be given our function, which is f. Okay. This is f of x comma y. This is equal to x squared e power x. Then plus what? Plus cos of y, then ln of x, then minus what? E power x squared, sinh of y. So to find, the first step, let us find it. So here I forgot, ladies and gentlemen, sorry, find it. And even in this state, I forgot. Find that. Okay? So in this state also we have to find it. We have to find f(1) x comma y. When y is kept constant. When y is kept constant. So we are looking the first derivative of function x comma y with respect to x when y is kept constant. So we are keeping y constant. So here we have partial derivative
with respect to x of what? X squared e power x. Then plus, we are keeping y constant. So cos of y, partial derivatives of x of 1 over ln of x. Then minus what sinh of y. Then partial derivatives of e power x squared.
Wonderful. So it's a kind of a challenging function, but don't worry. So now the next step, you have to differentiate each part. I differentiate each part. So here we have product of the two functions. So we go for the second step.
Let us find partial derivatives with respect to x of x squared into our x. We are using the product rule. So to find this, x e power x, we are using product rule. We keep x squared. We keep x squared constant. Then we are finding the partial derivatives of x with respect to x. Then plus what? E power x, partial derivatives with respect to x of x squared. Then the partial derivatives with respect to x of x squared e power x. This is equal to what? X squared e power x.
Okay? So if we differentiate e power x, we get e power x.
Then plus what? Plus e power x times what? Twice x. So ladies and gentlemen, partial derivative of x e power x of this is x squared e power x plus twice x e power x. So that's the derivative.
Then the next one is this function.
Then it's table. So let us find partial derivatives of what? 1 over ln x.
So 1 over ln of x. So there we have to use what? 1 over ln of x, you have to use quotient rule.
So quotient rule, we say that this is 1. You start the first one if you use there. So you say that partial derivative with respect to x of uv, this is equal to what? You used to start with v, partial of u, partial of x, minus u, partial v, partial of x, over v squared. So let this is equal to u, and this is equal to v. Partial derivatives with respect to x of what? Of 1 over ln of x. So what is v? Ln of x. To differentiate 1. 0 minus what? U 1. If you differentiate ln of x, you get 1 over x of what? Ln of x squared. So this is equal to 0, and this is what? Negative 1 of what? Over x ln of x squared.
Okay? So then we say that you have to find partial derivative with respect to x. So partial derivative with respect to x e power x squared. So with this one, you have to integrate x squared. So partial of p with respect to x is equal to x squared. Then partial of u with respect to p, this will be p on u. So to find partial with respect to e power x squared, because that's the function, is equal to, this is equal to partial of u, partial of p, chain rule, partial of p, partial of x. So simply this is twice x, e power u, which is e power x squared. So ladies and gentlemen, this is what the fifth state. First state. First state. So therefore, we say that ff1 of x comma y is equal to what? First, the response is x squared e power x squared e power x plus what? 2x e power x. Are the derivatives of this function. Then in this function we've got negative 1 of x ln of x squared. And the next function is what? Twice x e power x squared. So this is the response. Write it clearly. So say that 2xe or xe squared. So ladies and gentlemen, you see how the beauty of partial derivative, especially the first section. So let me leave you the homework. Homework what? Homework 5. So homework 5 means that in example 9, find ff2 x comma 1. So at the homework. Okay, ladies and gentlemen, this is the end of lecture 5, which titled as Introductions of Partial Derivative. So first of all, I thank God who have created me in His own image and likeness, and I thank God who have been with me in the preparations of this lecture, and I give Him all the glory and all the praise. And even yourself, you have to give God all the praise and all the honor for this great work that He has done in me. He has done it in you through my training and teaching. So I invite you to join me in the next lecture 60, where I will teach you now about the first principle of the three variable function. And the good news, I will solve one of the tutorial questions, which is question number 4 for the tutorial of the tutorial sheet 1, which provided at University of Dar es Salaam and even some other associated universities or institutions or colleges that are under TCU, and using the curriculums which are being accepted by the TCU, Tanzania Commissions for Universities. So don't miss it. I really appreciate and I really honor and I really congratulate you for joining me and for learning these contents. Remember to subscribe onto our YouTube channels that's titled, or that's called Online Undergrad Polyinstit of Tanzania (Olenjolaim). Share these contents with other undergraduate students. Ask the question in the comment section. Submit your homework in the comment section. Give me feedback, please. You enjoy this content from which institution, from which university, from which country, from which city, from which region, from which continent. Tell me in the comment sections, or you enjoyed this content from which college. Another thing I remind you, if you feel from your heart that you want to give God thanks for what He has provided, these materials are really worthy, these lectures are worthy, these programs are worthy. Okay, it can cost you a lot of money if you want to pay for it, but God is faithful because He's a sponsor of online undergraduate polytechnic Institute of Tanzania /Olenjolaim. I'm providing these contents free, not because I want, but because God, who have called me to be His teacher of higher engineering mathematics and higher scientific mathematics, instructed me to provide these contents free for the benefit of Tanzanians and other international students. But you have the windows of you and doors of you to offer your free willing thanksgiving to God, not to me, so this program, so you can participate or you can just contribute for the running cost of this program, so that more than 500 lecture videos of the 12 current modules or courses will be in air for the present and future generations, and they will be taught by using different teaching techniques, by using different ways of teaching, and by using different techniques and different teaching aids. So I ask you that you can send your free willing thanksgiving to 0759 745 3331, and registered name is Olenjolaim TAYAI. But in case you want to do the bank transactions, so you want to know more details, just read the descriptions of the video below. Click the buttons which have been written show more, so you see some more information and in show more, and even our online undergraduate library. You see the link there which will direct you into the special video and see how you can benefit from the resources that you're providing. So thank you very much. May God bless you and keep you safely. I ask you to pray for me. I ask you also, I have a responsibility to pray for you every day, so that the mission, the vision, the main objective of online undergraduate polytechnic Institute of Tanzania /Olenjolaim should be achieved without any kind of delay. It's a time to change. It's time to think differently. It's a time to think how you can find or apply the knowledge and wisdom you're learning in the classroom in order to solve real life problems. Stay tuned, stay focused, and then see you in the next lecture.